Please open the folder 3 Cyber Threats and Vulnerability Data Processing folder. And then open the slide named Automated Threat Report Classification PowerPoint. This is where the background material for this lab will be. The material introduces tactics and techniques used by attackers and methods which can be used to classify attack threat reports to tactics. After setting up your environment as shown in slides 2, Environment Setup PowerPoint, please open the lab folder. The lab folder contains the homework file and the needed files. Now we're going to open up the homework Word document file. This is where you can go to access the exercises. Now, question 1 requires you to build an SVM classifier to complete the exercise. Open the needed files folder and open up the threat report Python file. The file contains the code and you are required to complete the code. For the first couple of lines, we're going to import a few things. Like for this line, we're going to import the Panda data processing package. And then here we're going to import the NLTK natural processing toolkit. And in line 8, we're going to import TF IDF feature extraction module. As we look further down, we can see it contains variables. It contains variable for splitting the data into training and testing data. And here reads the data to training and test buffer. In line 79, it initializes the word stemmer module. And in line 82 and 89, it contains a definition to stem and tokenize the documents. At this line, it handles the TF-IDF feature extraction module. And here, it uses the TF-IDF model to extract features from the training and test buffer. At this line, it merges both the training and test data into a single buffer array. Using train test split, we partition the data to training and test data using random sampling. So for question 1, please initialize an SVM model as shown in the homework document. After initializing the model, train your model with the XTrain and YTrain data as shown in line 114. So for question 2A, we're going to calculate the accuracy of your model by comparing your prediction with the actual labels. For question 2B, by varying the value of the split ratio as shown in line 17, which is right here, we'll recalculate the accuracy. For question 3, please open the Word to Vet code file and copy the code and add the threat report Python file. Please replace with this decoration. So we're going to open up the folder. Okay, I'm going to go back to threat report Python, and we're going to modify line 107 to all data equals np.vstacks with the parameters tfs, comma, response. Please redo questions 2 and 3 as described before. As for the solution, we're going to open up the threat report solution Python file, which we found in the same folder. So let's open that up. Okay, let's go further down. Here, we will declare the SVM model. The CLF model is used to fit the training data. And at this line, The test labels are predicted. For question 2, right here, declares the count variable for correct classification. The my result contains the predicted values and the y test contains the actual values. We loop over the content of the list and compare the results as shown in this line right here. The accuracy is calculated by dividing the correctly predicted labels over the total labels. For question 2b, the split ratio should be modified in line 114, and the accuracy recalculated as described above. For question 3b, the solution in the threat report is in the threat report solution W2V Python file. So let's go back into our folder and open that up. Copy the content of Word2 vet code and add to the threat report Python file. So line 96, which is line 145 in our solution file, shows the modified code is shown below, and it should look like this. And line 107, which is now line 156 as our solution file, is modified to this. Rerun the experiments as described for a previous exercise and recalculate the accuracy of the classifier by running the code. So let's open up the terminal and your result should look like this.